Okay, welcome to 8.3 notes. At this point in our chemistry career, we can write out an equation based on a word equation. We can balance that equation. And now what we're going to do is we're going to learn about the types of the reactions. There are many types, but we're going to focus on just a few. The first one we're going to look at is this one called synthesis. Okay. Now notice right over here, I say composition. That's kind of the opposite of decomposition down here. And I've also heard this reaction called a combination reaction. It kind of depends on what text or what's your source. But our book calls it synthesis, so we're going to go with synthesis. Synthesis reactions are easily identified because you have two or more reactants right here, and they make one product. So here's a couple compounds making one big compound. So that's how we tell. Now, one of the demos that I did, and you can find this online if you want to look, is when we took some hydrogen gas, some oxygen gas, and we made some water. That was the one called the bottomless jug. But this is a synthesis reaction because we're taking two things and we're making one thing. Now, what I want to do next is I want to look at our reaction sheet that we practice balancing on, and let's see if we can identify some synthesis reactions. Okay. Well, right away you might see, oh, the first one, that thing plus that thing gives you this one reactant. Okay. So take a moment, pause the video, and try and circle all the problems that are synthesis reactions. Okay, did you do it? Well, here we go. Here's a single product, so 6 is the synthesis reaction. Here's a single product. 7 is a synthesis reaction. Here's 12, single product. 12 is a synthesis reaction. So is 14 and 16. All right. Hopefully that's what you matched and I didn't miss any. So that is a synthesis reaction, sometimes called a composition reaction. Let's go to the next type. Now the next type is kind of the opposite of synthesis or composition. It's called a decomposition. And decompositions are easily identified because they have one single reactant. Now, in this little generic reaction, B breaks up into A plus B, but you could have something called ABC, and it could break up into that. So it can, but the key is here, you've got one reactant. So in this little example right here, and if you look at the old foamy demo that I have online, this is what we did. We took some hydrogen peroxide, added a little bit of catalyst, NaI, and we made water and oxygen gas. So let's go back to our worksheet, see if we can't find some decomposition reactions. Well, I'll do the first one for you. Look at that one. Okay, so pause the video quickly and try and circle the other ones that are decomposition reactions. Okay, let's see how you did. Well, let's go to 5. There's a decomposition reaction. Again, we're looking for a reaction that has one reactant. Let's see if another one. Oops, here's another one. And oops, one last one right there. Okay, so there are decomposition reactions. The key is one reactant, all right? So there's 2 of the 5 we're going to go over. Here's 2 more. This first one's called a single replacement. Now the reason it's called single replacement is there is a single element that is going to replace one of the elements over here. And typically, if it's a metal, it'll replace the metal. If it's a nonmetal, it'll replace the nonmetal. Okay? How we identify them is we just look for a reaction that has that single element. Single element, single replacement. So let's go back to our sheet, see if we can find some single replacement reactions. Right? Well, let's see. Oops, here we go. Okay, the first one we find right here, I believe this is the first one, is right here. Okay? And the iron is going to replace copper. Okay? Pause the video, see if you can find some others. Okay, did you do that? I just noticed that I missed one. You might have been screaming it out of the screen, but here's carbon all by itself. So there is a single replacement where the carbon was replacing the oxygen. Okay, so let's look through the rest, see if you found them. Okay, let's see. Here's another one right here. Okay, and here's one right here. Again, the key is find a reaction that has a reactant that is all by itself. It's a single element. Okay. All right, on to our fourth one. Now this one's called a double replacement. And it occurs when you have two ionic compounds. And all they do is they just switch with each other. And what I mean by that is this right here, this cation, will combine with that anion. And this anion will combine with that cation. Almost like a pair of dancers, and they switch partners. Okay? So we've got iron chloride here and sodium sulfide. This iron is going to combine with the sulfur right there, and this chlorine is going to combine with the sodium right there. So that is a double replacement. Okay? So again, let's go back to this, see if we can find some double replacements. Go ahead and pause the video and just circle ones that you think are double replacements. All right, here you go. Right at the top, look at this. Ammonium hydroxide and mercury 2 nitrate. Okay, that's one right there. Okay, let's see. There's not too many left, right? Oops, here's another one. Silver nitrate and sodium carbonate. So there's another double replacement. Oops, here's another one. Okay, we're noting that we're seeing two ionic compounds. They're just switching. And that looks like it. Okay, on to our last one. Our last one we've seen before. It's called a combustion reaction. And usually you have some kind of hydrocarbon. Like in this case, we have propane, and it's going to be bonding with oxygen. It's going to be burning, and you're going to make carbon dioxide and water. And I usually just tell everyone, hey, look for a reaction that has carbon dioxide and water. That is your combustion reaction. And if you want to watch the methane bubbles, okay, you'll see this reaction, which is an example of a combustion reaction. So let me just go ahead and balance that thing. There you go. Okay. So let's look at our sheet and see if we have any combustion reactions. Well, there's not very many left. So if I look here, here it is right here. Okay. That's the only combustion reaction of the whole thing. All right. So hopefully this stuff makes sense. Again, if not, come see me. We'll practice and get you better at this stuff. Hope everything's working well. If not, come see me. Bye.